Our goal today is to write and interpret direct variation equations. So what is a direct variation? A direct variation is a linear function with the y-intercept at 0. That means that this equation, if you were to graph it, it's going to go through the origin. So the definition is a linear function with the y-intercept at 0. It goes through the origin. There are some examples there, y equals 7x, or if you're using function notation, f of x equals 4x, or y equals 2/3 x. Notice that when I write 2/3 x, that x is next to the fraction. It is not on top nor on the bottom of the fraction. If I wanted to write it on the top, that's where it would go, but I did not put it a part of that fraction. So the constant of variation is the ratio of y to x. It's also going to be the slope of the direct variation equation. So the constant of variation for this first example right here would be 7. The example here, the constant of variation would be 4. And this example here, the constant of variation would be 2/3. It's considered the k value if we were to write y equals kx. K is treated just like m, the slope. Y equals kx or y equals mx. So this is written y equals kx. It's very similar to y equals mx plus b, except for the b is your y-intercept. But we had said that the y-intercept is going to be at 0, which is why you don't have to write plus 0 here. Now, if you were to solve for k, which is, again, your slope, get k alone, you would divide both sides by x. K would be by itself, and over here you'd have y over x. So k is the same thing as y over x. That's how you can figure out what k is, okay? Knowing that it goes through the y-intercept means that it's always going to contain the point 0, 0. So let's look at a couple different tables. Okay, so looking at this table, we have the x values 3, 5, 9, and the y values 21, 35, 63. So what we need to do is we are going to have to figure out what the k value is for any of those points. So basically, you're going to find the slope as if 0, 0 was a point and 321 was a point. But we can do that easily because if you're subtracting 0 when you're taking the rise over the run, if one of your points is 0, 0, then really you're just doing y over x. So as we said, we can figure out k by doing y over x. Here, if we figure out what our k value, y is 21 over 3 is 7. Here our k value would be 35 over 5, which is 7. Here our k value would be 63 over 9, which is, again, 7. If you're looking at a table and your k value is constant, okay, so k is constant, then this tells you that this is a direct variation equation. So you can say that the equation is y equals 7x y equals 7x. Our constant of variation is your k value, so k was 7, and you can say that yes, y varies directly with x. Okay. Next, we're going to do the exact same thing. We're going to go ahead, we're going to find our k value. Remember that your k value is found by taking y over x, the change in y over the change of x. But again, the change, if you're going from 8 to 0, is just going to be 8. If you're going from 2 to 0, it's just going to be 2, which is why we don't have to worry about subtracting 0 there. All right, so let's go ahead and figure these out. 8 over 2 is 4. 16 over 4 is 4. 32 over 6 is, if you do these on a calculator, you're going to get 5.3 repeating. I know we don't usually use decimals in this class, but again, you're not using it as a decimal right now. Typically what you would do, or another way you could write this, is 32 over 6 and then reduce to 16/3. That would also be acceptable. Either way you do this though, you can see that your k value was 4 for the first one, it was 4 for the second one, and then it changes to 16/3 or 5.3 repeating. So in this case, your k value is not constant. Since your k value is not constant, if you were to draw those 3 points and the point 0, 0, you would not be able to use a straight edge to connect all 4 points. So because of that, y does not vary directly with x. Okay. If we're working with an equation here, from an equation, what you're looking for is, does this equation look like y equals kx? So what you can do is you can get y alone, and does it look like this? For the first example, we have negative 2x plus 3y equals 0. And for this example, we're going to have negative 4x plus 2y equals 6. So what you want to do is you want to get y alone. So this first one, example 3, you can add 2x on both sides. You're going to have to divide by 3 on both sides. Y equals 2/3 x. Now, does that look like y equals a number x? Y equals kx. Y equals a number x. It does. So this one is a direct variation equation. If we're asked to write the equation, that would be our equation, which I'm sure it will ask that. The constant of variation we will be asked to find. And that's your k value, so k is 2/3. And you can state that y varies directly with x. For the next one, we're going to get y by itself. We're going to add 4x to both sides. We're going to get 2y is equal to 4x plus 6. We're going to divide everything by 2. We're going to get y equals 2x plus 3. And you look at this, and yeah, that looks familiar. It's a linear equation, y equals mx plus b. But is this a direct variation? And it's not, because for direct variation, it has to go through the origin. So your y-intercept would have to be at 0. And if you're looking at this right here, the y-intercept is at 0, 3. So it's a linear equation, but it doesn't go through the origin. So for this, we can write y does not vary directly with x. Okay, so notice on this one, example 5, it says y varies directly with x. If that says that phrase, what it means is y equals kx. So varies directly with means equals k. The y part is in the beginning, the x part's at the end. So y varies directly with is equals k x. So right here translates to this. Okay, so we need to know that because right now it says water wasted varies directly with time. Okay, so what we're going to do is we're going to assign a variable. So maybe you would like to assign y to be the amount of water wasted. Varies directly with time would then be your x. So when we write y equals kx, that's from this sentence right here, where y is equal to your water wasted and x is equal to time. Now we still have to actually say how are these measured. So it says after 3 minutes, 1 cup of water was wasted. So that tells me that your time is measured in minutes and the water wasted is measured in cups. Okay, and so since it gives us this after 3 minutes, 1 cup of water was wasted, they just gave you a point. Okay, that point said the x was your time, so time was 3, and the y is your water wasted, which was 1, so that's a point. Now, you guys actually know another point, right? Another point, because this says varies directly with, we actually know that there's another point, 0, 0. Now, you don't need that, though, because we really need to find our k value to be able to write our equation. So that's key information, but it's not necessary, because we can figure out our k value by just doing y over x. Or plug it into your equation and figure out what k is and then rewrite your equation. So your k value is going to be 1 over 3. So y equals 1/3 x. That's your equation. Okay. Now, what does it actually want us to find? It says how much water is wasted after 4 minutes. So they want to find out this other point. They want to know how much water is wasted. So they want us to tell them why, and they tell us it's after 4 minutes. So that's your time. Okay. So what we're going to do is we're going to use the equation we wrote, y equals 1/3, and we're going to plug in what we know, which was the x was 4. Y equals 4/3. Okay. So that means 4/3 of a cup, or 1 1/3 of a cup of water is wasted at 4 minutes of time. Okay. There is another way you could have solved this, and it's using proportions, which we're going to do in example 6 here. So we said that your k value, if we use this first point, your k value would be, remember it's y over x, so this one would be y1 over x1. Okay. If we wanted to use this other point, then your k value would be y2 over x2. However, your k value always has to be the same. So that means that we can use either of these, meaning that y1 over x1 has to be equivalent to y2 over x2, because when you reduce them, they have to both be k, and your k is constant. That's your constant of variation. So if you can set up this proportion right here, then you can go ahead and solve for a missing variable of a point. So given that y varies directly with x, let's say they give you the problem x is 27 when y is negative 51. Find x when y is negative 17. Okay, so the first point they gave you was 27, negative 51. And then that next point, so that comes from this information here. The next point they gave us was this right here. We don't know what x is, but we know y is negative 17. Okay. So the first way that we can do this is we can start by writing an equation. So use this point right here, find your k value, which would be y over x. And that reduces to negative 17 over 9. And from there, you have an equation, y equals negative 17 over 9x. Okay. So then what we can do is we can use the point that we know and plug it in to this equation. We can use the y that we know and plug it in and solve for x. So we have negative 17 for y equals negative 17 over 9 times x. And now you can get x alone. So I would multiply both sides by negative 9 over 17. And your 17s are actually going to cancel. That's going to become positive 9 on the left. And over here you just have x. So your x is going to be 9. That's one way to do it. So use the point that you know to write an equation, and then plug in the variable that you know to the equation to find the unknown variable. The second point is actually using proportions. So as we said before, you have these 2 points, 27, negative 51, and the unknown x, comma, negative 17. What you're going to do is you're going to use the idea from up here, where that your k value is always the same. We can set up this proportion. So we know that the red is 0.1, so we have negative 51 over 27 has to equal, and then the blue one, so your y is negative 17 over the unknown x. Now what you can do is you can cross multiply. Okay, so when we cross multiply, You multiply these two, set that on one side, multiply these two, put it on the other side. So we end up with 27 times negative 17 on one side equals negative 51x on the other side. Well, this is negative 459 equals negative 51x. Divide both sides by negative 51, and you're going to get that x is 9. So it doesn't matter which way we use because we get the same answer either way.